Okay, so let us now do some example problems. First, our first problem is a definite integral from 0 to 2 of x dx. Here, we have x to the 1, so our n is equal to 1. By the reverse power rule, we have 1 over 1 plus 1, x to the 1 plus 1. And in this case, since it's a definite integral, we set up the evaluation. We use a vertical bar, evaluate from 2 to 0. We get 1 half 2 to the 2 minus 0 to the 2. In this case, this is still 0. So we simply have 2 to the 2 over 2. Or when simplified, just becomes 2. Now, the second problem, we have the indefinite integral of x squared dx. Following what we did in the previous example, n is equal to 2. Therefore, we have 1 over 2 plus 1, x to the 2 plus 1. Because we don't have any boundaries to plug in, we have to leave a constant, which we call plus c. And so our end result is 1/3 x cubed plus c. From over here, we have now this problem, which states the integral from 2 to 4 of cosine of x dx. Over here, using the property, we can undo this cosine by noting that it's simply sine of x, evaluated from 2 to 4. We have sine of 4 minus sine of 2. In this situation, we have to assume that 2 and 4 are in radians, because plugging in simply 4 and 2 without noting that it's degrees becomes misleading. Okay, the fourth problem, we have the integral from negative pi to pi of sine of x dx. Once again, we have sine, so the integral of this becomes negative cosine of x, evaluated from negative pi to pi. So over here, we have cosine of pi, and we have minus minus, or we have minus minus, so it becomes a plus cosine of negative pi. Now, over here, cosine of pi becomes negative negative, so we have just simply we have just simply 1. But cosine of pi, because cosine is even, is negative 1. So our result is 0. Now we have a little bit of a harder problem, which is 3 functions in 1. So we have the integral from negative 1 to 1 of x cubed plus cosine of x plus 3 sine of x. The way we do this problem is by breaking it up into 3 different integrals and adding them up all together. So another way to say this is the integral from negative 1 to 3 of x cubed dx plus the integral from negative 1 to 1 of cosine of x dx plus 3 is a constant with respect to dx, so we can pull it out. The integral from negative 1 to 1 of sine of x dx. From here, we can evaluate this to be 1 over 3 plus 1, x to the 3 plus 1, evaluated from negative 1 to 1. Over here, this becomes sine of x, evaluated from negative 1 to 1. And from here, the last one, we have the following. negative cosine of x, evaluated from -1 to 1. Okay, so from here, this right here, we have 1/4, 1 to the 4, minus 1/4, -1 to the 4. This will cancel out. Over here, we have sine of 1 minus sine of -1, assuming this is radians, plus 3 negative cosine of 1 minus cosine of -1. Based on this property, that cosine of x is the same as cosine of -x, these two also cancel out and become 0. So we are left with 2 sine of 1 as our answer. Thank you.